Okay, everyone, welcome back. So I was in the middle of finishing up problem number 4. So just to recap, so we're given 5 liters. We're given a 5 liter tank of propane. So we got 5 liters of propane gas at 13 atmospheres and 10 degrees. So they're giving that information, and they want to know what volume of oxygen at 10 degrees and 103 kilopascals will be required to react with all of the propane, right? So they're giving us volume of one gas and we're asked for volume of another gas. And so if you're given one volume and you're asked for another volume, you're going to have to use PV equals nRT or molar volume in the beginning, and you're going to have to use PV equals nRT, the ideal gas law, or molar volume at the end to go from moles to liters. So you got to go from liters to moles, and then moles to liters at the end. So I'm going to using PV equals nRT to go from volume to moles of gas A. Use the mole ratio here to go from moles A to moles B, to go from propane to oxygen, and then to go from moles of oxygen to liters. I'm using PV equals nRT. And so I did all of that. And so now we're at PV equals nRT. So here I used PV equals nRT, solved for moles, plugged in the values for the propane that I was given, converted the temperature to Kelvin, and then I got moles, so 2.8 moles of the propane. Then I used the mole ratio of 1 mole of propane to 5, which I got from my balanced equation. So I convert moles of propane to moles of oxygen, and now I have my moles of oxygen. I have the temperature, 10 degrees Celsius, which is again 283 Kelvin, and I have 103 kilopascals. So I'm going to solve my equation for volume because that's what we want, and I'll plug everything in. So I got volume is equal to number of moles, RT over the pressure. And so I'm going to plug that in. So I have moles, 14 moles of oxygen. So that's going to be 14 moles multiplied by R. Now, since I have kilopascals, I can use 8.31 kilopascals liters over mole Kelvin for my R. So that's 8.31 kilopascal liter over Kelvin mole, and then multiplied by the temperature, which again is 283 Kelvin. And finally, the pressure, which is 103 kilopascals. And so I can cancel stuff out. So moles cancels out, Kelvin cancels out, and kilopascals cancels out, leaving me with liters. So great. So now I can do the calculation, and I get and I get 320 liters. So 320 liters of oxygen is required to react completely with this amount of propane I'm giving in the 5 liter tank. Okay. So again, hopefully that's what you got. And if that's not what you got, hopefully through this process you realize your mistake and you won't make that mistake again. So let's finish up with finally number 5. So hello everyone, welcome back. So it turns out I don't have a 5th problem. I only have the 4, so you are saved. So that's it for this video. Let me know what you think. Also, make sure if you like this video, if this was helpful in any way, please by all means like the video, share the video, hit that like button over there. Also subscribe to my channel. Make sure you hit that notification bell when you do, hit all so you'll be notified by all videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. If you've got questions, let me know. I'd love to hear from you. If you have a problem or a question you want me to answer, feel free to ask me, and I'd love to do a video on it. Thanks for joining me, and have a great day.